Hello, everyone. In this lesson, we're going to focus on one of the key principles for designing a study. Okay, before we can actually make a good quality study, we have to have a good understanding of what data we're interested in. What characteristics of our population are we really interested in? So we're going to introduce in this lesson some of the basic terminology and involved that applies to variables, that applies to data. So the very first question is, what are data? You've heard that in the first place, or you've heard that often enough, right? And we're not talking about data from Star Trek, right? Data is just any fact or characteristic that you can then use about the population that you can then use in calculating and reasoning and planning. Okay, the world is driven by data, so he who controls the data controls the world, right? So you guys are going to gain a lot of experience and understanding of how to deal with data. So let's write this definition. So what did we say? We said data are facts or characteristics, if I can spell it, about the population that you're interested in studying. And those facts we'll be able to use, we'll be able to analyze them, right? So they'll be used in our calculating, reasoning, or planning. Again, data is what keeps things running smoothly. So in just about every profession that you're going to have, you're going to be expected to somehow, directly or indirectly, be a part of gathering data that can then be analyzed to make whatever business it is run smoother. Okay, a lot of careers depend heavily on research, and so maybe you'll be required to actually look over some research studies that have been done, see what conclusions have been made, and make decisions accordingly. Okay, so now we jump from data, okay, to a variable. Now, a variable in statistics is quite different. Well, it's very different from what you learned in algebra class. Okay, a variable is actually being tied to the data that we're collecting. Okay, so this variable is going to be, again, our characteristic of interest. So about our target population. Okay, now variable implies that something is varying, and that variation happens. So this variable will vary from one entity of the population to another. Okay, and so when you first start to design a study, you'll have to come up with some research question. What are you interested in studying? From that research question, the variable and the data that you need to collect will be fairly apparent. Now, there's going to be different ways to classify the data and variables that you're going to use. So the first way that we're going to talk about is, or the first type of data or variable that we're going to talk about is what's referred to as quantitative or numerical data. Okay, sometimes it can be a little misleading because this doesn't mean that every number is quantitative or numerical. Okay, you got to look at the role that that number plays. Typically, this quantitative or numerical data involves some type of numerical measurement. And going even beyond that, it's a numerical measurement where operations like addition, subtraction, multiplication, division, averages make sense. Okay, so some examples of quantitative data would include what? What are some things that it makes sense to average them? What's the type of data? Yes, I heard some of you over the ether say height, right? So a height is, you can collect heights from a lot of different people, and then it does make sense to find an average height. So for our class, we could find an average height of everybody in our class. Okay, so the average makes sense for height. Some other examples, you have weight, you have temperature, even things like a year or time. Those all are quantitative variables, okay, because an average makes sense. Okay, so if you know that the variable is quantitative, now these only apply to quantitative variables, to quantitative data. So there are two types. For quantitative variables, we could have a discrete variable or a continuous variable. Now these are terms that will come up later on in your math classes, possibly, but definitely in statistics, these are big. So essentially, a discrete variable has a countable number of outcomes. Whoops. Countable, if I can spell it. Number of values. Okay, and so something that is either finite, okay, so there's just a fixed number of possibilities, like what are the how many freckles do you have on your face, right? The number of freckles on a person, there's only so many that could be possible, and you could count them, okay? You could count the number of students in our class. So the number of students in our class would be a discrete quantitative variable. Unfortunately, the money in our bank account is also accountably a finite number of possibilities. Now, discrete variables could actually be infinite as well, but countably so. So if you think of the set of natural numbers, our counting numbers, right? You can count 1, 2, 3, 4, 5, and you can go up as far as you want, but you can keep going, but you're not getting, so even though I have 1 and 2 in there, all the values between 1 and 2 are not a part of that set, right? So another example of discrete. So again, typically when we're talking statistics, a discrete variable just has a countable number of values. There's so many that are possible, and you can count them. So flipping from there, we can go to continuous quantitative variables. Now, these have a lot more values, Okay, the continuous variables are uncountable. So could be paralleled to our set of real numbers, right? So you can pick any two numbers, say the 1 and 2 that we talked about before, but in for a continuous variable, you can't just have the values 1 and 2. You can also have every value in between them. 1.1, 1.5789. You can have irrational numbers as a part of these possible outcomes, right? So a continuous number is uncountable because it follows on the number line. It would cover every value there. Okay, so what are some examples of a continuous variable? Well, we came up with some before, right? Those examples in the previous question, that height is actually a continuous variable, because I could be 5 feet tall, I could be 6 feet tall, but I can also be 5.5 feet. I can be 5.678 feet tall. Okay, the only limitation to the accuracy of the value is whatever tool I'm using to measure it, right? But theoretically, height could be any amount, even all of those decimal amounts, okay? So height, weight is another example. So continuous. It's uncountable. There's an infinite number of possible weights you can have, okay? Okay, so again, discrete and continuous only apply to quantitative variables. Now, there are a lot of variables that are not quantitative, variables where an average does not make sense. So we call these variables qualitative or categorical. Okay, they're talking about qualities or categories. So I guess a definition. So data that describes entities by placing them in categories. Okay, or groups, okay, by some characteristic. So for these qualitative variables, an average would not make sense. Okay, so what's a type of data that tells you a characteristic of something, but you can't really average it, or an average will be meaningless for us? A lot of you are latched on to hair color, right? So hair color, brown, black, blonde, red, several categories of color that are available. But if I was to find all the hair colors of everyone in our class and then find our average hair color, on average, we're a dark blonde in our class. That's not really meaningful for us, right? So hair color is a qualitative variable. Similar, so eye color, those are also examples. Say your favorite type of music. That's, again, a qualitative, categorical variable. You could even have something that says, that gives you levels, but which you still can't average, right? If I ask you how happy you are, what are the possible things you could say? There are several. I could give you just a specific range just to keep things simpler, right? I could say not very happy, mildly happy, or very happy, right? So you can pick one of those, and even though there's some kind of an ordering to those values, it doesn't make sense for me to take not, very, and mild and average them together. Okay, so it's still a categorical or a qualitative variable. Does that make sense? Awesome. So the next question, just to hit a previous point home a little bit, what are some qualitative variables that may involve numbers? But in the case of these numbers, an average of the number would not hold much meaning for us. Can you think of any? You use a lot of these all the time. What about zip codes? Okay, what's the purpose of the zip code? Easy way for us to be able, or at least for the post office, to be able to tell quickly what region a specific address belongs to, right? So even though a zip code is a number, like our E from Z zip code, 84, do I remember it? 627. Okay. If I took a bunch of zip codes, everyone's zip code in our class, and averaged it together, on average, our zip code is 82191.79. That doesn't make sense, right? So zip codes are actually categorical. Even though you use a number to categorize, it's still serving the purpose of categorizing, in this case, addresses or locations, right? Your phone numbers are also in this category, right? Phone numbers, an average phone number will be useless, right? But it does involve numbers. Your social security number, right? Another example, UPC codes. Everything you buy is going to have a barcode on it. Yeah. The barcode just makes it, that UPC code just makes it easy again for the computer system to quickly identify what that item is. And so it can charge you the right thing. So awesome. Also qualitative, it's just to categorize things. The numerical form of it just makes it more convenient to use and to process the information. All right, so you've made a point. All numbers are not quantitative. You have to look at their function. In the case of these few examples we just talked about, these are all numbers that are actually categorical in nature. Make sense? So now that you have a decent background of quantitative and qualitative variables, what is an easy way? So if you were given a list of variables, what's an easy way for you to determine if they're quantitative or qualitative? Getting a lot of thoughts out there. I recommend just this question. Just ask yourself, does an average of that data, of those values, make sense? If an average makes sense, then it's a quantitative variable. If an average does not make sense, it is qualitative. Good? All right, so file that away. Make sure that's in your notes. Great way to tell, okay? In exams and assessments throughout this class, different variables are going to come up. It's very important that you know how to classify them as quantitative or qualitative, because the decision you make on that, the type of data you're using, will influence the type of test that you will need to do, the type of analysis that you will run in your study. Okay, so very, very important. Latch onto that. So now, besides just quantitative and qualitative, there is another way to classify these variables, and that's using what's called the level of measurement for the variable. Okay, so we have a couple levels of measurement that are appropriate for each of our categories. Note, for a nominal and ordinal variable, those are categories for qualitative data. The interval and ratio, those are categories for our quantitative data. Okay, just to make that distinction. Don't take a quantitative variable and call it nominal, okay? It won't make sense. So what do these mean? Well, I know that just because I told you that nominal and ordinal represent qualitative data, that means both of these should represent categories of things, right? They should be filing away, classifying these entities, subjects in our study as some kind of category or group. Specifically, nominal data is specifically names, categories, or labels. And more specifically, for those labels, there is no implied ordering of them. Okay, there's no logical order. So some examples that we talked about before, our hair color is in there, right? Just classifying all the hair colors. So we have red, blue, well, I guess some people have blue hair, red, blue, brown, black, right? So hair color is simply a category. Your favorite music, that is a category. So it doesn't make sense to order them a specific way either, right? For example, if I had the hair colors blonde, brown, and black, there's not necessarily a logical order of best to least or least to best, right? Because that'll vary between individuals. That's an opinion type thing. So there's no logical way to order them. Favorite ice cream flavor is also in there. Gender is in there, right? So those are qualitative variables that are simply classified by certain categories or groups. Now, ordinal is different. Note the ordinal data is also made up of your names, categories, and labels, right? Because it's qualitative, and that was part of our definition of a qualitative variable. But for the ordinal variables, there is a logical ordering. Okay, from least to best. Okay, so one of those examples that we just talked about was how happy are you, right? So if that's what we're collecting data on, and your options are not very happy, mildly happy, or very happy, there is a logical ordering to that, right? We can order them from the least to the most. However, it doesn't make sense for us to average those options together. So that locks us still into a qualitative variable, qualitative data. However, it is ordinal qualitative data. Note in the name, there's our clue. Ordinal leads to order. There is a logical order to these qualitative variables here. Got it? So nominal, just names and categories, labels, but order doesn't mean anything. There's no logical ordering involved. However, for ordinal qualitative variables, there is a logical ordering involved. So you'll often get scales like this when you're talking about ordinal variables. Okay, so jumping to the quantitative category, there's two specific types, or two levels of measurement. The first one is an interval level of measurement. Okay, so again, so note for quantitative variables, order always matters, right? So for interval, data can be arranged in order. And the differences between values is meaningful. No, differences between, those are intervals, okay? So the differences between values are meaningful. Now, the distinguishing thing about interval variables is that there is no true or absolute zero. Zero isn't as low as you can go, basically. Okay, so an interval variable could have 0 as a possible value, but you could go lower than that, right? And higher than that. So what are some examples then of quantitative variables where there's not an absolute 0? Can you think of any? What about temperature, specifically in degrees Celsius or degrees Fahrenheit? Unfortunately, you can get temperatures below 0, even though that makes us sad, right? It gets really, really cold, though that does mean snow gets up on the mountain for those of you that like skiing, snowboarding, whatever. You can still go below 0, right? This past winter, we had, here in Utah, we had several days that were much colder than 0 degrees Celsius, colder than freezing. Okay. We dealt with it. We muddled up. We were still able to have fun, but 0 is in the middle of the scale somewhere, not the lowest. What some other examples? Well, we have like time, as in the, say, the year, right? So if it's, what year is it? 2019, 2020. Those years, is there a 0 year? So the years that we typically measure from are AD, right? So after Christ, or I don't even remember exactly what it stands for. Okay, but there is you could go back the other direction from that 0, and you get you get BC, right? Before Christ, we have another scale going in the negative direction from 0. So years are interval variables. Altitude, how far above or below sea level you are, that's also interval, right? Because you can go below 0 into the ground or below the level of the sea. Okay. What about ratio? If you know the interval variables have no absolute 0, stands to reason that ratio variables have an absolute 0. So quantitative data that has an absolute 0, what are some examples? Where 0 means you don't have any of it, right? So some of those that we've talked about, height is one of these. It's a ratio variable. You can't go lower than a height of 0. You're at a height of 0, that already means you pretty much don't exist, right? But 0 is as low as you can get. Same thing on your weight. If you have a weight of 0, you're pretty much a ghost, okay? So height and weight are both ratio variables. Now, you could throw in temperature if you specify specifically that it's in Kelvin. Okay, temperature measured in Kelvin, 0 on the Kelvin scale is absolute 0. That's as low as you can get. All right, so to determine between interval and ratio variables, you just ask yourself, is there an absolute 0? Okay, if there is not, it is an interval variable. If there is, it is a ratio variable. All right, so we've talked about some great things today. So you've learned to classify variables as quantitative or qualitative, and by their level of measurement. So now that you've completed all of this, hopefully you filled out your individual prep sheet along with me or put this information in your notes, you will use it quite a bit later on, and you will be tested on it. So if you don't have any questions, you're good now, ready to go and jump in with your group and work with them to practice a little bit more. Remember that if you do have questions on any of this stuff, contact your instructor, talk with your group, do it sooner than later so you can get those questions answered. All right, y'all have been awesome. I will check in with you later.